Monitoring a Kubernetes cluster allows operators to track the resource utilization of the containers within that cluster. In today's episode, Ilan Rabinovitch joins the show to explore the different options for setting up monitoring and some common design patterns around Kubernetes logging and metrics gathering. Ilan is the VP of Product and Community at Datadog. Earlier in his career, Ilan spent much of his time working with Linux and taking part in the Linux community. We discussed the similarities and differences between the evolution of Linux and that of Kubernetes. In previous episodes, we've explored some common open source solutions for monitoring Kubernetes, including Prometheus and the EFK stack, that's Elasticsearch Fluentd Kibana. And since Ilan works at Datadog, we explored how hosted solutions compare to self-managed monitoring. We also talked about how to assess different hosted solutions, such as those from a large cloud provider like AWS versus vendors that are specifically focused on monitoring. Full disclosure, Datadog is a sponsor of Software Engineering Daily. Failure is unpredictable. You don't know when your system will break, but you know it will happen. Gremlin prepares for these outages. Gremlin provides resilience as a service using chaos engineering techniques pioneered at Netflix and Amazon. Prepare your team for disaster by proactively testing failure scenarios. Max out CPU, black hole, or slow down network traffic to a dependency. Terminate processes and hosts. Each of these shows how your system reacts, allowing you to harden things before a production incident. Check out Gremlin and get a free demo by going to gremlin.com/sedaily. That's gremlin.com/sedaily to get your free demo of how Gremlin can help you prepare with resilience as a service. Ilan Rabinovitch, welcome to Software Engineering Daily.
Thanks for having me.
You've had a variety of operational roles in the past. You've spent a ton of time with Linux, and the main focus of the conversation today is going to be Kubernetes and specifically monitoring Kubernetes. But given your experience in the Linux community, how does the Kubernetes world and the growth of Kubernetes compare to those early Linux days?
So I think containers in general and Kubernetes specifically have been seeing a ton of growth in the last couple of years. We publish a Docker adoption study every year at Datadog where we're just seeing it's in some cases 5xing year over year, growth on containers. And so I think, Kubernetes is sort of tied at the hip with containerization. And so we see a ton of growth there. I think it took a while for the world to jump on the open source bandwagon where now it's open by default. And I think that's helped quite a bit. I think the cloud ecosystem growing at the rate that it is has also helped quite a bit. But I would say, containers and Kubernetes are probably, I would say are probably growing at a faster clip than Linux was at this age.
It could just be that could be a byproduct of the technology, or it could just be a byproduct of the volume of developers that have increased in that time span.
Yeah, I think it's a bit of both, right? You have the number of developers has increased significantly, of course. The number of folks that are using open source platforms in general has increased as well. Like it used to be there used to be some challenges and sometimes bringing into certain organizations. These days, I don't think you can find any organization that's not using some amount of open source. So that's helps as well. I think the speed at which folks are trying to develop and deploy to the cloud and just the sheer number of systems that we're all managing now has also forced us to take a look at new tooling and adopt it quickly when it helps us manage at scale. So
you were witness to the container orchestration wars. I was covering this topic pretty closely. You also saw the evolution around virtualization that happened before these wars. You saw AWS get started. You saw OpenStack. You probably saw VMware's rise. Do you have any broad takeaways from watching all of this virtualization technology come of age and quickly deprecate other pieces of technology and just all the churn?
Yeah, I mean, I think the short story is everything old is new again, right? We were all well, maybe I wasn't. It's before my days in technology, but at some point, everybody was time sharing on large mainframes or shared computing platforms, and we moved towards more dedicated things. Towards the beginning of my career, VMware started showing up everywhere as a way to save money. We'll run. Don't worry, we don't need 10 computers. We'll just run them all on one, and it'll be fine. That usually tended to be an attempt at cost savings, although I think usually a poorly thought one. Not that anything was bad with virtualization, just that, again, that idea that you're going to take the workloads of 10 machines and shove it onto like one equally sized machine and assume it's going to be the same was probably a mistake. And then over the years, we saw Zen supplant that, and since then, and containerizations like technologies like OpenVZ started off. But I'd say, like I said, everything old is new again. Things we sort of seem to run in circles. It's just always the goal always just seems to be the same. Let's get work done faster and more efficiently. We think it's pretty safe to assume that containers probably have we'll have some sort of a shelf life here as well, and we'll see something new come along in the next 10 years that will supplant them, or at least take some of the tension away again, or at least maybe maybe different than the containers we see today, maybe some evolution of them. I would say the other thing OpenStack I would say is interesting is we're diving into, if we look at that specifically, was just that every industry seems to grow and shrink. And that's OpenStack is exciting. I think though, as more folks and more folks are focusing on public cloud or utility computing type situations, they're realizing they don't necessarily have the expertise to run these types of things, like to run these types of systems in-house. And so they look at organizations like Amazon or Google or Azure or any other number of organizations out there. And so where I see OpenStack focus these days is on the providers that need to run it for their own customers or for very large organizations, whether it be telcos or large, many tens of thousands of node environments. And I don't know, we'll see. I'm curious to see what the dance between OpenStack and Kubernetes continues to look like. Not
to go down a rabbit hole, but OpenStack, I think the ancestry there is that it was either pioneered or shepherded by Rackspace and some other companies that have a giant amount of infrastructure, and the infrastructure is so tightly coupled with what they do that they would not move to the cloud in any time in the foreseeable future.
They are the cloud.
They are a cloud, right?
I mean, if you think about the providers that you're talking about there, they are the cloud.
Right. But OpenStack is for managing lower level infrastructure rather than, I mean, does it compete with Kubernetes, or it has some sort of Venn diagram overlap with it?
There's a Venn diagram overlap. When I chat with folks, I hear sort of one of two stories. One is, well, of course, something needs to manage the underlying infrastructure, or I'm an IS, infrastructure as a service provider, and I'm offering that up to my customers, and they in turn run Kubernetes on top of that. I think there was a use case in which some organizations maybe were diving down that path, diving into OpenStack, diving into infrastructure management at a scale that they probably didn't need it at. And in those situations, it's possible that abstraction layer may not necessarily be useful anymore. They can, working with, Kubernetes directly on the host rather than offering everybody the opportunity to spin up VMs on which they might in turn run Kubernetes. Maybe that meets their needs now.
What are the pros and cons of that model? Like, I don't know if you're an expert in that, but the version of running Kubernetes on top of a bunch of VMs versus running Kubernetes just on bare metal instances.
I mean, I think there's a bootstrapping problem that nobody likes to talk about, which is whether it's OpenStack or something else, you still got to get the software on the machine. You still got to provision them. So you're still, I don't know, whether you're using some form of PXE booting still or something else, right? You still got to get the bits onto the machine when it gets to you from Dell or HP or one of the open compute vendors, right? So whether it's for OpenStack or for Kubernetes, like that management layer is important. What I'm finding when I talk to some of our larger customers that are that may still be using it, that are still running their environments in their own data center or have a very large data center of their own, they have lots of teams doing lots of different things. It's not just Kubernetes, and so by offering up a common API on which you can provision VMs for your own needs, then that makes it simple for the infrastructure team to then in turn support a large swath of folks. In terms of why you would want to run it directly, I mean, if you don't need a virtualization hit, why take a virtualization hit?
Yeah, fair enough. Kubernetes' effect on competition between cloud providers has been exciting to watch. And in my coverage of this, initially I walked in thinking, okay, Kubernetes is a way for people to avoid lock-in and be able to migrate from one cloud provider to another. And that may be true, but it seems like in reality, what is happening is people are spinning up clusters of Kubernetes on multiple cloud providers. Are you seeing that same trend? Are you seeing people migrate from one cloud to another? Or are you seeing more likely people are just standing up Kubernetes on both clouds and using it as a kind of common runtime to interface with whatever cloud-specific services they want on that particular cloud?
Yeah, I mean, we have when we talk to our customers, they fall into both of those camps, which is or all three, which is they may be looking to move between one cloud provider and another, and Kubernetes is offering them a common way in which to think about their application deployments and their compute scheduling across those providers. There's others that are trying to do the multi-cloud thing, as you mentioned, which is great. Not everybody definitely helps to mitigate some risk by being in multiple places, whether it be a negotiation risk or a technology risk or wanting to just be more geodiverse in your deployment. Even business requirements, sometimes you find yourself in situations where contractually you have to be in one provider or another. But I think at the end of the day, it's really not about helping people move between cloud providers. It's about offering a simpler and more robust way to schedule your compute resources. And the fact that it's letting folks move around between them, it's helpful, but I don't think that's the primary purpose for most folks moving to Kubernetes, right? If you're super invested in Amazon or you're super invested in your own data center, it's nice to have an out, but you've already built up a bunch of competency there. You're likely not just it's not likely not just like, let me containerize all the things and we're going to move elsewhere, right? You still have, if you have a ton of data in S3, the data gravity of moving things out of S3 is quite high, right? Especially that the volumes that many of our customers have, right? There's a great story in Wired from about a year ago from Dropbox about their move from Amazon to their own data centers and the amount of effort and time it took them to orchestrate and just transfer all of the data that we all take for granted and stored in this nebulous cloud thing that they call Dropbox out of S3 and out of EC2 and onto their own systems. Like that was a lot of work, and I don't have a ton of inside knowledge there. I mean, I'm sure there's a great show there for you to do in the future about that whole project. But
in the past, actually.
Oh, sorry. I guess turns out when there's a show every day, it's hard to keep up.
Exactly.
But yeah, I mean, how much of that work was about like standardizing APIs, and how much of it was just like the pipes only move so fast? So
totally. Yeah, that was a great case study in infrastructure. We actually have a show airing this week with Tammy, who was the lead of SRE, I think, on that project. And so SRE, you can imagine SRE on a project where you're building your own S3-like infrastructure had some interesting tales to tell.
Yeah, I'm sure that'll be fun. I know she's also doing quite a bit of interesting things with chaos engineering these days, so I'm looking forward to that show.
That's right, and she talked about why to do chaos engineering even in the context of a massive data migration. So it's promising for the idea of chaos engineering. If you're supposed to do it then, you're probably supposed to do it all the time. So let's get into monitoring. Today, we're going to talk about how to observe and monitor Kubernetes, but to get there, I think we should first talk about how people monitored raw Docker infrastructure, because Kubernetes has been around for a bit shorter period of time than Docker, and Kubernetes is managing Docker instances for most people. How did people monitor raw Docker infrastructure, or how do they if they have not moved to Kubernetes yet?
So I think it depends on your environment. Some folks some folks aren't using containers in the dynamic way that that you might under Kubernetes or another scheduler, right? Just like folks had at some point were sort of lifting and shifting their work into the cloud. Like, oh, I don't, where they're not necessarily thinking about these things may go away. It's just like, I don't want to run VMware anymore, or I don't want to run my Zen hosts anymore. Let me just go drop this on AWS. It'll make it their problem. Folks have taken, early Docker users were, in some cases doing the same, whether it might be just, using Ansible or some other tooling to just, Docker run a container on their machine, in which case things don't change too much for you monitoring wise, right? If it's static, the tools that you've had in the past likely still work for you. Things that you might want to get out of Docker while you're still there are, the Docker socket offers a wealth of metrics via Stats API that they offer there, and you want to get that to be able to get some of your get details on all the different resources that your individual containers are using, whether it be compute or memory resources or just any of the underlying raw resources. The thing I'd say to everybody, that's whether you're thinking about Docker in that sort of a static environment or a very dynamic environment like Kubernetes, where we see containers churning all the time, is, don't forget to focus on your application. Everybody, a lot of times when we start to dig into monitoring, everybody, the first reaction is, well, let me look at all the resources on the machine. Let me look at disk. Let me look at memory. Let me look at CPU. Let me look at how much throttling I'm seeing on those containers, things like that. All of that's really important. But at the end of the day, people are probably tired of hearing me say this, but nobody ever calls you up in the middle of the night to say, hey, the website's running fine. All those orders are processing. We're good, but the CPU is a little high. Could I get a refund? Like, that just doesn't come up. And so what you really want to focus on is your actual application. And that application could be, the technology that you happen to be deploying there, whether it's a data store or, like Redis or MySQL or Postgres or something else. And you want to just see, what you're interested in are things like the query times from those, from those data stores and the throughput that they're doing and how are they performing for their end customers. Or it could be your actual web application, in which case you want to look at, your 500s and your 200s and just make sure that like your actual application is responding the way you're responding in a way that your customers are going to be happy with and they're going to keep paying you. And those could be internal customers or external customers.
This episode of Software Engineering Daily is sponsored by Datadog. Datadog integrates seamlessly with container technologies like Docker and Kubernetes, so you can monitor your entire container cluster in real time. See across all of your servers, containers, apps, and services in one place with powerful visualizations, sophisticated alerting, distributed tracing, and APM. And now, Datadog has application performance monitoring for Java. Start monitoring your microservices today with a free trial. And as a bonus, Datadog will send you a free t-shirt. You can get both of those things by going to softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. Were there aspects of monitoring that were difficult in a scenario where there was no container orchestrator in the pre-Kubernetes world where people just had these Docker containers?
There's always aspect of monitoring that became difficult with containers is very similar to what was difficult with VMs in the cloud when you were doing sort of auto scaling groups. We've just sort of turned it up to, I guess, in non-orchestrated world, we turned it up maybe to 5. Once you get to orchestration, you turn it up to 11, as they say, and things are just moving around all the time. I think there's what folks started to realize as they moved there is that maybe some of their is that they really couldn't use monitoring that relied on static configuration files, monitoring tools that relied on static configuration files to track where things were. Like, it doesn't matter how fast how tight your chef run loops are and like how quickly you're converging. If you've got it on a 5-minute converge loop, like, that's great. You might have whatever you were using to deploy your containers very quickly, whether it was static in the way you're discussing or Kubernetes later, right? Like, it's moving faster than your monitoring system, and that's going to be a problem.
So engineering teams, they're moving to Kubernetes, and we've covered this in previous episodes. When people move on to Kubernetes, they're going to have some existing monitoring infrastructure in place. Once they add Kubernetes, are there new things that need to be monitored?
I think similar to the conversations we had earlier, there's all kinds of things that need to be monitored about Kubernetes itself, whether it be the control plane or the API server or the kubelets on each of the nodes. And so you want to be able to pull all that data in. What becomes interesting is how to is again trying to monitor your application as it moves around like that. And there's all kinds of different, as Kubernetes starts to move it around for you. And there's all kinds of interesting approaches. You can, whether you're using Datadog and doing that, or there's a couple of approaches where you can, put some of your monitoring tooling in a sidecar next to your applications on Kubernetes. There's, pull-based approaches with things like Prometheus. The gist is, you want to make sure that your tools can keep up with you as your workloads are shifting underneath your feet. And that's by design, right? In the static environment of our data centers of old, where you started on your first day and they assigned you a server, and you said, like, there are many like it, but this one's mine. I'll keep it running for my time here at whatever company you're at. It was okay to set up your monitoring, and what normal was, and it would alert you when something was different. When normal is now the VMs changing every 5 minutes because of auto scaling groups at your cloud provider, and the container is changing even faster than that because of Kubernetes scheduling or your other scheduler moving things on your behalf. You're going to want to normal changes all the time, so you're going to want to be able to figure out how to do that in some sort of programmatic or algorithmic way, figure out where things should be, determine what your service health is, and sort of monitor it from that perspective. Being able to monitor, I guess the other things I'd look at in the world of Kubernetes are not just, not just individual pods, but rather like your service as a whole, or your deployment as a whole, and seeing where they're at. Are there enough replicas do the replicas match what you expected to schedule, things of that nature.
Talking about what we're going to monitor, you're always monitoring resource usage metrics like CPU or memory usage. What are the other metrics that you're going to want to be looking at across your cluster?
I think you're going to want to look at those metrics that you mentioned and start to take a look at how if you're running the Kubernetes cluster, you're going to want to look at how efficient your users are taking advantage of the resources that you're providing them. So you're going to want to be able to look at that and break that down by application or by service or by pod, and see kind of where your waste is. In terms of there's other resource metrics, of course, like storage and network, et cetera. But I think if you're a Kubernetes cluster administrator, what you should be thinking about is the service that you provide your customers, which is the schedule, which are likely internal customers if you're providing it to at a company. And you're going to want to look at your work metrics there, which is what you do there as the service that you're providing your organization is the schedule of compute. So how many failures are you seeing as folks try to schedule workloads? How long does it take between when you schedule, when somebody tries to execute a deployment and when it actually occurs? And you're going to want to dig into that I probably sound like a bit of a broken record, but you really want to look at it from from the experiences that your internal customers are having, and those are the folks that are deploying their apps. There's all kinds of ways to access those metrics. It might be, again, there's a number of APIs on the control plane. The kubelets themselves offer some APIs as well. Digging into logs is helpful as well. But you're going to want to look again at how successful are you at offering your customer, the developer trying to deploy an application on Kubernetes, at meeting their SLAs you have with them.
What about etcd? So etcd is the tool that is managing the consensus of the state of your cluster. And if etcd was having some kind of issue, that would be problematic for your cluster. But do I need to monitor that, or can I just trust etcd?
So, I think like all things, you definitely want to monitor that etcd. Not having that leaves you in sort of in a state that's not ideal. The cluster won't fail, but you're going to be in a spot where you might not be able to schedule or make changes there. I think like all the components that underlie Kubernetes, etcd is something that you're going to want to keep an eye on, and we offer a way to integrate with etcd and pull all the metrics from there. I think the other thing to keep in mind is that a lot of folks that are running etcd often may run it off cluster and separate from their Kubernetes infrastructure. And if they're doing that, then you're likely not benefiting from the scheduling and sort of guarantees that Kubernetes might offer you for that etcd cluster.
Kubernetes has a base monitoring platform called Heapster, and Heapster aggregates monitoring and event data. It runs in its own pod, and it's communicating with the nodes across the cluster by querying the kubelets on those nodes. Can you talk about what Heapster does and why it exists in a Kubernetes cluster?
Sure. So, Heapster is one of is sort of the original metrics aggregation and monitoring tool that came with Kubernetes by default. The frequency of collection is user configurable. I think it's set to about a default by a minute, but you can get it to down into the high seconds level range. Folks tend to use it. In the past have used it because it was there by default. But there was a lot of these days. It's in the process of being deprecated. My understanding from the instrumentation SIG, folks are starting to focus more on some of the new metrics APIs. Heapster, when it was there, at the moment supports a number of different sinks or backends where it flushes those metrics too, and so that might be, there's ones like StatsD, there's Influx, there's Google, the Google Stackdriver, and a bunch of other vendor solutions. And so there was a lot of challenges with, keeping up with those implementations and the differences between how those different sinks interacted and stored and propagated the data. The community has sort of moved into a different direction these days. That being said, it's still, in the past, it was useful for things like digging into how to do auto scaling and other things that required metrics within Kubernetes itself.
That term SIG, that is special interest group. So you mentioned that there is a instrumentation special interest group. What is this? This is a group where they discuss the state of monitoring and logging and instrumentation around Kubernetes? Yeah,
Kubernetes has a SIG for pretty much everything. So if there's more than 2 people in the world that want to do a thing, there's likely a SIG for it. It's maybe a little bit of an exaggeration, but the instrumentation SIG is where all the different monitoring vendors, as well as the core Kubernetes developers that work on the metrics subsystems, get together on a regular basis to chat about how to collect and about what those APIs should look like, what the future of things like Heapster looks like, and sort of the roadmap for monitoring and metrics within the world of Kubernetes.
This is one thing I find interesting about the Kubernetes community is that there are all these commercial interests. You go to a KubeCon and there are so many vendors there. It does make me wonder, what's the diplomacy like there, or is there a very shared sensibility to what APIs Kubernetes should offer that make it easy for any kind of instrumentation company, vendor to build on top of Kubernetes?
Yeah, it's surprisingly cordial. I mean, I think and so far it feels better. I mean, it feels better than what I saw in the world of OpenStack, maybe, 5+ years ago, where in the world of OpenStack, it felt like every vendor would show up and, there would be some implementation they'd be looking to create an API or a service that represented their technology solution in a way that made it work with OpenStack. And it was always interesting to see what actually got accepted there and what moved in. In the world of Kubernetes, it feels like there's better abstraction layers. I don't want to sound that, I guess that maybe that sounds a little negative on the OpenStack side, but it feels like the SIGs have done a better job of ensuring that we come together and work towards a common standard that then we all implement. And so right now that you can see that instrumentation SIG, where there's been a bunch of new metrics APIs. Before it, there's been development of a new metrics API. As that metrics API matured, you saw a number of vendors come forward with sort of implementations of their own for how to consume or send metrics via it.
Yeah. So those metrics on a cluster, do they get stored automatically, or does it come down to the vendor choice or the metrics implementation choice to decide how to store metrics, how long you want to keep them around for, how they can be queried? Is that the job of this kind of tooling that people plug into their Kubernetes cluster? So, I mean, there's the Heapster bit that we were talking about earlier. And yeah, that was, by default, it used InfluxDB, although there was a bunch of different other choices you could make. A lot of the details, though, that you mentioned around, how things are stored and how long you're going to keep them around for, and at what granularity, and are you going to roll them up or not roll them up, and, how do you alert on them? What do you do with them? That's sort of all belongs in the world of that monitoring tooling and the vendors that consume from those APIs. So where do the logs from a Kubernetes pod get written to?
So it's interesting. Kubernetes doesn't really have a centralized logging offering, right? They get, when container users are often will generally log to standard error, standard out from their applications, whether that's a general pattern within the world of Docker as well. And so what folks tend to do is run either a sidecar that will monitor that standard error, standard out, and grab that, or they run a daemon set, which will ensure that they've got a container on each host collecting all the logs. But they're not really centralized in any sort of a way in the world of Kubernetes. So
describe that sidecar pattern. How do people use the sidecar pattern for logging in Kubernetes?
In Kubernetes, you have the concept of a pod, which is a bunch of, is one or more containers that are going to be deployed together. What the sidecar pattern is taking a utility, whether it be a monitoring or a logging, a log collection agent, and you're including it in that pod alongside your application workloads. There are other reasons you might want to include multiple containers in a pod. Maybe there's that are actually more relevant to your application in terms of having multiple pieces that are actually working together to serve the traffic that container may need to, or the work that container may need to do. But in the case of monitoring or metrics, you're just going to have, or logs, you're going to have that your collection agent alongside your application and picking up those logs and sending them off to your, whether it's your internal log store with something like Elk, or if it's your, a hosted provider like Datadog. You're sort of looking to have a separation of concerns within your application, and that those sidecars are taking care of it.
Yeah, and I think there's also another popular stack. What is it, the F stack or something? That we did a show about FluentD a while back. What is FluentD? What's the role that FluentD plays in a logging pipeline?
I mean, I'm by no means a FluentD expert, but FluentD seems to be quite popular in the world of Kubernetes. It is one way in which you sort of route your logs to the various solutions you may want. It has ended up in the CNCF as well, alongside Kubernetes and some of the other tools. But it's a data collector that you can use to route your logs to wherever you may want them. FluentD is one of the ingest solutions that Datadog would support, for example, for our own logging pipeline and product.
When we're talking about these kind of solutions, like I do want to talk about Datadog because you're a company that makes monitoring tools. What do you have to build to support Kubernetes users?
So of course we need to integrate with all the different pieces that make up a Kubernetes cluster, whether it's Kubernetes itself and collecting metrics from a overall cluster at a cluster level, whether that be scheduling events or logs from your masters in the various API servers. Could be we want to make sure that we monitor things like all your ingress controllers and your etcd and all of the other tools that kind of come together to make up a functioning cluster for you. At the same time, though, often we find that folks are often focused too much on that. We do build out integrations for all those things. We've supported them since before Kubernetes 1.0. But the place where I think Datadog spends a lot of our time is on making it easy for application developers to monitor their applications on top of Kubernetes. So whether that's be traces from your applications in the open tracing sense, and making sure that you're able to see where your requests are spending their time and how they're crossing service boundaries and host boundaries, or logs in terms of making sure that we can collect all your application logs in addition to those cluster logs, and make sure that we've kind of made easy to deploy patterns for that. And then finally, with things like auto discovery, we want to make sure that we can make it easy for you to automatically detect containers as they're spinning up and down, and see, and monitor them for what's inside them, not just sort of like, oh, here's another Docker container, here's CPU or memory or what have you, but really being able to monitor the things that are inside those containers. Most recently, one of the things that we added late last year was a live process view and a live container view in the Datadog product. So if you think about things like CTOP, which lets you see, container stats across your hosts, or HTOP or top, that's letting you focus on processes, we realized that folks have all of these metrics at their disposal for the health of their cluster, and then they still, occasionally still catching people SSHing places or running to their kube control commands to get data from their cluster. And so we realized that a lot of that really had to do with data recency and wanting to have like a real-time index of all of your data. So rather than having you run CTOP across all your different hosts, what we built was a centralized way for you to be able to look at it across the Datadog product, and then be able to dive into each of those containers and even see what processes are running inside them and the resources that they're using. So those are some of the examples of the things that we built to make Kubernetes monitoring interesting and useful and real time.
Engineer chaos. Don't let chaos engineer you. When systems fail, you need to be in control. VictorOps is the incident management tool that you need. VictorOps provides a comprehensive view of your system by integrating with a large number of monitoring, alerting, and communication tools that your team already uses. It's your one-stop shop for diagnosing an incident, escalating and alerting the proper engineers, collaborating during the firefight, and resolving the problem. Through detailed notes, logs, runbooks, and graphs, you can see the information you need in real time and also create detailed post-incident reviews after the fact. Head to victorops.com/sedaily. That's victorops.com/sedaily to see how VictorOps can help you. Go to victorops.com/sedaily. Be victorious with VictorOps. So I know that at least one model of deploying Kubernetes monitoring is through the daemon set, which a daemon set makes a particular pod run on every node in the cluster. Is the daemon set the approach that you take for when you have users that want to deploy monitoring across an entire Kubernetes cluster? Is that what they're doing when they deploy Datadog, for example? They're deploying a daemon set?
Yeah, that's sort of the get up and running real quick model, and that's the one we generally recommend. Is you deploy a daemon set on your cluster, and automatically you're now monitoring the overall cluster, as well as have the ability to monitor the applications running that are being scheduled on top of it. So the daemon set's quite useful for monitoring any systems management tools. But that's the way we approach monitoring metrics. Monitoring from a metrics logs or tracing perspective by default. It's the recommended path. But in some cases, customers may not be the cluster administrator. They may be running in a hosted environment where they don't have the ability to run a daemon set, right? If it's a multi-tenant environment, or there may be, what have you. And so in those situations, the sidecar approach is definitely something we can support as well.
When you're building a monitoring product, do you want to enable people to auto scale their cluster in response to things that are detected in the monitoring data that is being created within the Datadog product, for example? Or do you want to just make a tool for observing, and somebody that's on call can just look at and do you want the cluster to be able to respond to data that is generated by that monitoring product?
I think you want the option for that. So, in general, Datadog is, likes to be a benevolent observer, right? We want to be able to watch what's happening in your environment, help you better understand it, and not necessarily take particular actions on your behalf. That being said, we have a number of customers that will do things like, whether it be pipe our data back into auto scaling groups at the various cloud providers to get more control there based on application metrics or service metrics, and that's a popular pattern. Similarly, in the world of Kubernetes, you have folks that are doing pod auto scaling, where they want to scale up and down the number of pods based on workloads and schedule more resources there. And so you definitely want to be able to inject those metrics back into the cluster in some way. That's something that the Datadog team is working on.
So Datadog is a hosted service in contrast to people who self-manage their own monitoring tool chains, whether it's open source or not. How important is the hosted service aspect of it? Because you talk to other people who are building hosted services, oftentimes it's useful to have some auto scaling component or the uptime guarantees, for example. How does the usage of a hosted provider, compare to self-managed or open source monitoring solutions?
So I'm a big fan of open source. Been involved in the open source community for most of my career, and so I think it's lovely to see all the that we're finally getting some attention on open source tooling in our industry around monitoring and systems management. There was a sort of a bit of a dark ages there for a little bit a few years back, but it's good to see that things are coming together again. That being said, much like any other open source versus hosted or proprietary solution, really what you're making is a decision there based on core competencies for your organization, time available, whether or not you want some of the support options that are available. Of course, there's lots of organizations that sell support on those open source solutions. I think the piece around outsourcing a lot of this problem to somebody else whose challenge that is important and something to keep in mind, right? I used to run monitoring systems myself internally at various organizations when I was wearing my operations hat. And to do it well, it's not a trivial amount of time, and that's before you even get to the point of figuring out what you wanted to monitor. It's just thinking about how the time series data store in which you keep all of these things. How are you going to scale that out? How are you going to keep it online? How are you going to monitor it? Not to sort of, I guess that's a bit of a catch-22, but you want to do all the things. But you want to. There's a lot of effort that goes into making those monitoring systems highly available and useful to the end users in your organization. And that's where vendors like Datadog come in, and we help make that a much easier experience for you, and a much more integrated experience across the different tool sets that you have, whether it be again tracing metrics and logs, being able to switch between them and sort of pivot on a log and see the metrics that are associated with it, or vice versa. That's quite important and quite helpful to sort of reducing your time to addressing issues if you're having an incident, or identifying issues before your customers have noticed it. And so I think that's where hosted providers like Datadog can really help reduce your workload and let you go back to focusing on building your own applications and building the things that make your company a success.
And what's on the roadmap for Kubernetes support? What are you working on at Datadog?
Right now, we've been let's a couple of things we've been working on. We've got some new features we'll be announcing at KubeCon here in a couple weeks around visualizing your containers. I'd definitely keep an eye out for those. We're continuing to improve our support for things like supporting the Prometheus format, which will be probably by the time this episode is out, that'll have been released. And then finally, we talked a little bit about horizontal pod auto scaling and the idea of wanting to bring your metrics back into your cluster operations. And that's also something that you'll see coming out here fairly soon from Datadog.
So what do you think about these newer ways of managing resources? Like, it's obviously serverless, and then there's these standalone container instances like the Azure container instances or the AWS Fargate instances. Have you looked much at these different solutions for managing resources?
Yeah, we got to spend a lot of time with the AWS team on Fargate as that was getting ready to roll out. We were one of their launch partners, so got to spend a bit of time with that. ACI is has a similar approach, and something that we're playing with quite a bit as well. It's interesting, right? When we were already saying for a while now that the host is not what folks want to focus on in terms of their monitoring systems. You wanted to focus on the services that run on top of them. This just helps us take it to helps us drive that point home. That's another great place where that sidecar approach really falls in that we were talking about earlier, right? Is how do you monitor? There's no host on which to run our agent. There's no host on which to run a log, something that does log collection. So you want to drop those inside your tasks. I think these are all great solutions that are helping folks focus on their applications and innovate more quickly as they're trying to deploy the services that their businesses are either depend on or that their customers depend on. So more and more abstractions like this is great.
And the difference between using a cloud provider product versus using a non-cloud provider vendor-specific product, that's a choice that a lot of people are making decisions between. For example, like I know AWS has their own suite of monitoring tools, and Datadog has their own suite of monitoring tools. How do you talk to people about, like, potential customers about the differences between, like, choosing, okay, you're already on AWS, they're thinking maybe we should just go with the AWS monitoring tools. How do you convince them to go in a different direction?
So I think the features and the functionality that we offer really end up speaking for themselves, as well as the ability to look across cloud providers. Most of the cloud providers, AWS included, have a fairly coarse granularity at which they store their metrics. They rolled up those metrics over time quite aggressively, so that after days or weeks, you're no longer able to say what exactly happened at a given point in time. Instead, you're looking at an average of what happened over the course of an hour or a 5-minute window, which is
So it's like garbage collection, like a log garbage collection.
It's sort of like what you had in RRD when we were doing like Cacti or any of the other monitoring tooling back in the day, right? It's a way to reduce costs. It's a way to improve performance as you're querying the data and looking at it over time. Datadog doesn't do that. We keep all of the data for 15 months at full granularity. So if you sent us a metric now and we come back next year this same time, you'll still have that, and you'll be able to say, like, how did that software engineering daily episode impact the traffic on my website? I can tell you a year, I can tell you, looking at that year over year or month over month, right? That's important. Also, we have deep integrations with all the different cloud providers. So it's not just, what's on your server. We're also pulling metrics from your storage providers and from like S3 or Azure Blob Storage or, similar services at Google and other cloud providers. So the ability to kind of look at that super deeply, connect it with your application data from our integrations from the agent, right? Most of those cloud providers are really focused on, those underlying resource metrics. Their monitoring tools are really focused on telling you, are they providing you with the resources that were scheduled for you, and are you using them, right? Whereas, Datadog's focused on helping you monitor that 360-degree picture for your environment. So we want to help you monitor that application server or that data store or that web server that's sitting on top of your instances. And so when we have so the Datadog product helps, is going to help you look across all of those things, and then as well as cross cloud provider. And that's usually, by the end of that conversation, people tend to realize that we're the right solution for them.
All right. Well, just to close off, I know you've been looking at the usage data of people who are working with Kubernetes. And obviously, Datadog has access to lots of anonymized data about how people are operating their clusters. What kinds of surprising trends are you seeing involving Kubernetes?
So, one thing we saw, one of the trends that we have a whole study up on the website, and maybe something we can link to from the show notes. But things like the frequency at which containers churn between Kubernetes and ECS, we found that Kubernetes users tend to have much shorter lifetimes on their workloads than folks on ECS do. Some other surprising things we've had, the number of people running data stores inside containers, whether it's on Kubernetes or not on Kubernetes, is much higher than we were expecting. So like in the top 10 containers, you have top 10 technologies people are monitoring. You have things like Elasticsearch and Redis and MySQL, right? These are MongoDB. Like these are all things that I did not expect to see, as we were digging into the data for containers early on or even later with Kubernetes. So stateful services are, definitely becoming a more popular thing to run there. I've just been surprised by how quickly people are diving into it.
And it surprises you because it's bold to put your central data store of record on Kubernetes?
To be honest, it's hard for me to tell you what people are doing in there. I can tell you what technologies they're running, right? But it's hard for me to say, is their master database sitting inside, on top of Kubernetes? I think it's just people tend to think about containers and orchestrated workloads as a place to put their stateless services. And so as we dive into, as we see people running stateful services there, it's just, at least at first, it was surprising. And every time we run the report, I'm just kind of wondering who's going to come out in the lead in terms of the technology we see there. So that's been, like Nginx, when Nginx came in number one, I was not surprised at all, right? Like it's right. It's definitely like the web server of choice, it seems, within the world of containers. When I saw Elasticsearch coming in number 2 on Kubernetes, I was like, I'm a little surprised by that, but okay. As we started to get into things like Postgres and MySQL and MongoDB, I was also a little, surprised. But these days, it's just, again, not to make it it's not a popularity contest, but it's just interesting to see what comes out on top, if only to see how the patterns and how people are using containers and orchestrators are changing. Well, other things, other stats I could talk about. I think it's been interesting to see how deployment patterns and best practices have emerged on top of, with containers and with orchestrators, right? I think if we went back to the early days of any programming language of your choice, let's say we'll go with Ruby, and you had people, playing with dependencies and their gem files. They probably started off there, also not pinning to particular versions. And when things blew up, starting to build other tools that made that, starting to build other tools or starting to lock that down in their environments. I think we're seeing a similar trend in the world of Kubernetes. We see something like 80%, 75 to 80% of our customers are really just are pulling tons of images that have the latest tag on them, where it's just like whatever Kubernetes every time Kubernetes spins up a pod, it's going to pull for whatever the latest container is and pull that down. That's maybe living a little dangerously. I think only about 10% of our customers last time we ran the study were looking at just we're pinning their container images to like specific versions. It'd be interesting to see how that progresses over time, and if folks start start to get burned by that and lock down to specific versions. But yeah, I'm looking forward to digging into more stats. So if any of the listeners have specific things, their specific questions around Kubernetes you're interested in, just drop me a tweet. I'd love to dig into them in our next study.
And we'll certainly try to cover the evolving notion of stateful applications on Kubernetes. Well, Ilan, thanks for coming on Software Engineering Daily. It's been really great talking to you.
Thanks. Good. Thanks for having me on, and it's been fun.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily, and thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow!